Alright guys, so this is just going to be a quick walkthrough on Bandit. It's a pretty beginner level, like war games, quote unquote. That's what these terminal-based kind of hacking almost games are. But this one's essentially to teach you a little bit of the basics in Linux commands, and it's more for just aspiring hackers, I guess. It's for anyone who's trying to actually get fluent in using the command line in Linux. So we'll start off with level 0. Okay, so level 0, log on using SSH, username bandit0, host is bandit.labs.overthewire.org, and the password is bandit0. So let's try it. Do SSH bandit0 at bandit.labs.overthewire.org. Oh, I almost forgot to say port 2220. Click that. So this will pop up when you are SSHing into a host you've never done before, so that's fine. Yes. Password bandit0. And there we go. All right, to progress to level 1, we need to find the password for level 1, and it tells us it's located in a file called readme in the home directory. So we're right here from level 0. Let's clear that. Look for the file using ls, and the easiest way is to cat. And there's the password for level 1. All right, level 1 to level 2, we see the password is stored in a file called hyphen, located in the home directory. So let's go and SSH to bandit1 this time. And we enter the password we got. And here we are. So, looking at the files, we see there is indeed a hyphen, but you can see the trip up here is if we try to do that, cat thinks that there's going to be an option after that. And so the easiest fix is to do a dot slash hyphen, and dot slash basically tells us that this is a file in the current directory. Dot is how you say something's in the current directory in Linux. We do that, and we get the password. All right, level 2 to 3, the password is stored in a file called spaces in this file name, located in the home directory. And so just for convenience sake, I'm skipping the part where I SSH and enter the password because I'm pretty sure you could do that by this point. But let's see if the file is there. So spaces in this file name. All right, so the problem here is the spaces actually. If we do that, it thinks we're trying to cat a bunch of separate files. And so the way to solve this is, actually, let's just go one up. If we do backslashes, it cancels out the spaces in the terminal. So we just go and add a backslash in all of these, and boom, there's a password. All right, level 3 to 4, it tells us the password is stored in a hidden file in the in here directory. So let's see it. We'll change directory into in here. And if we just press ls, it doesn't show anything because it told us it's a hidden file. But if we do ls-a for all, we can see it's right there. Cat.hidden. And there's our password. All right, level 4 to 5, they say the password for the next level is stored in the only human readable file in the in here directory. So let's go over here, change directory to in here, and let's look at the files. So they're all the same except for the last thing, and so here we can do a little fancy shell scripting. We could do for I in, you gotta do the dot slash because they have the hyphens in front. File 0 wildcard do, which now we're entering a loop for each file and that we just declared here in the wildcard. Do file, and this will tell us the type of file, and then $I goes back to this I variable we just declared right here. Do file I, done. So we could see file 07 is the only one with just straight ASCII text. So if we do cat dot slash, because it has the hyphen in front, file 07, and we have the password. All right, level 5 to 6, file, or the password is stored in a file somewhere in the in here directory and has the following properties. It's human readable, 1033 bytes in size, and not executable. So if we come back to Bandit 5, we'll see that in the in here directory, there's a lot of directories. So maybe we could look at one, and there's a bunch of different files. So it's not really feasible to do this by hand. Here we'll use the find tool. So find will recursively search through the directories, and we could apply a argument onto them. So we could do -exec, and here we're going to use the stat command. And what do we want to do with the stat command? Well, we'll come right here, and we have the man page for stat, and we could print off different things about the file, right? And so we're going to use the -c, the format option. And so if we come down to the ways we could format it, we'll see exactly what we need. So we'll see the permission bits and file types. So that's one thing to search for non-readable. We will see the file name, which would be nice because we'll need to look at it later. And if we come down here, we'll see the block size, which is the number of bytes. And so if we come back to Bandit 5, we'll do stat-c, and we'll start it. So $N for the file name, S for the file size, and capital A for the permissions. And we'll need to give it an argument, so everything that find got, and we'll do the // or sorry, we need a backslash in that to stop the stat. So if we enter that, we're getting a lot of files. So you can look at it. We'll grep, which will look for patterns for the number 1033, which should be the bytes. And it's right here, in here, file 2. So if we cat that, there's our password. All right, level 6 to level 7 is telling us the password is stored somewhere on the server and has all the following properties. It's owned by Bandit 7, owned by the group Bandit 6, and 33 bytes in size. Okay, so let's come back to Bandit 6. So the first thing we need to do is navigate to the root directory so we can search over the entire server. So go here, and we'll see we're in the root directory. So we have to recursively list all the files. So we can do that with the ls command -r, and we're going to do the long option to print off the size and who owns it. And this is something we have to do. We don't have permissions to view all the files. So doing this to dev null will give all the error messages to dev null, which is basically throwing them away. And so this will list all the files, their permissions, and the sizes recursively in the entire server. And next we'll have to grep and look for a pattern. And the pattern that the ls-l will give us will be Bandit 7 for the user and Bandit 6 for the group. And that's just how ls will print it. So if we do that, we'll let it run for a sec, and it sees bandit7.password is what we need to find. So coming over, we need to actually find where that file is. So if we do find-name and copy that name, bandit7.password, and we'll also do the errors to dev no. Let that run for a sec, and it's right here. So if we cat that file, we have our password. All right, level 7 to level 8 is telling us the password is stored in the file data.txt next to the word million. And so this one's pretty easy. Make sure we have data.txt, and we can use the grep command to grep for the word million in the file data.txt. And there's our password. All right, level 8 to 9 is telling us the password is stored in data.txt and is the only line of text that occurs once. So we'll come back here and look at data.txt. Let's just look at it. And it's gigantic. So we can use the unique command. So the unique command filters adjacent matching lines from input. And so what we need to do is do cat again, and we need to sort it so we can put all the adjacent duplicate lines together. And after we sort it, we could use unique, and with unique we have to use the option -u to only print unique lines. So if we do unique -u, we have our password. All right, level 9 to level 10. It says the password is stored in data.txt and is one of the few human-readable strings preceded by several equals. And so to deal with this, instead of the cat command, we're going to use the strings command. And the strings command prints sequences of printable characters, which is basically a word for human-readable. So if we do strings data.txt, we get all of the printable sequence that are at least 4 characters long. And so what we need to do now is, after that, we'll grep for, we'll say 3 equal signs. And we get the password. The password is this. All right, level 10 to level 11, it says the password is stored in data.txt and contains base 64 encoded data. So to deal with this, we will use the command base64, which encodes and decodes data and prints it out. So we're going to use it with the -d command. So we'll come over here, make sure data.txt is there. We'll cat data.txt, and after that, we'll send it to base64 with the -d command. And there we have our password. All right, level 11 to level 12 is saying it's in data.txt. All the lowercase, uppercase letters have been rotated by 13 positions. So we come here, we cat data.txt, we'll see it's essentially a Caesar cipher. And so we can actually use the TR, which stands for translate. And so we could translate the characters, and I'll show you how to do that right now. So if we cat data.txt, we'll send it to TR, where our input is capital A to capital Z and little a to little z. And the output, we're going to rotate by 13 characters, so A goes to N, N to Z, and then A to M. Sorry, I was thinking about it. And then a little case, N to Z, A to M. And we get our password. All right, level 12 to 13, it's saying it's stored in data.txt, which is a hex dump of a file that's been repeatedly compressed. So it's telling us to make a directory under temp, which we could work on using makedir. So we'll come here and make a new directory under temp, mp, and we'll just call it my username. So we'll change directory into that. Or actually, we'll copy data.txt to that directory first. And then we could change directory into that. So now we're here. So if we cat data.txt, this is what a hex dump looks like. And so the way to deal with this is we'll use the xxd tool, which makes a hex dump or does the reverse. So if we come down here, if we do the -r function, it actually reverses the hex dump into a binary. And so we cat data.txt, send it to xxd with the -r command. We'll send that output to a new file, which is called data2. And if we look at data 2, we'll see that it's a gzipped compressed file. So we'll rename that. Let me clear up this. We'll rename. So yeah, we can verify that it's gzipped with file. Sorry, I was jumping ahead of the game. But we're going to rename that to data2.gz. Now, do gzip, sorry, terrible spelling, gzip-d data2.gz. We're going to get back data2. And so, file data2, it's still, right now it's a bzipped file. And so we're going to have to do this a couple times. So move data2 to data2.bz for bzip. And then we're going to do bzip to data2.bz. Sorry, it's a gzip, bzip 2. Now we have data 2. So we'll see that again. Now it's a gzipped. And so move data2 data2.bz bzip -d data2.gz. And we have data 2 again. Let's just clear it up. Let's see what data 2 looks like now. It's a tar, so move data2 to data2.tar. And this one takes a while. I'm sure you could automate it, but it's just kind of going through it. Data2.tar. So we're going to do tar, and to extract it, we do with x. F is, for file, is data2.tar. And C. And we have data5.bin. So if we look at file data5.bin, it's another tar archive. So to data5.tar. And then we're going to do tar again, tar xf data5.tar. And that gave us data6.bin. File data6.bin. And now it's another bzip2. So move data6.bin to data6.bz. And then bzip2-d data6.bz. Now let's see what data 6 has. It's another tar archive, and so we're going to do it again. Move data 6 to data6.tar, r-xf data6.tar, and now we have data 8. So let's see data 8. Another gzip. So data8.bin to data8.bz or gz, and then gzip decompress data8.bz. Oh, sorry. Gzip, not gz. And now we have data 8. So let's see, file data 8 ASCII text. So we could finally look at it, and we have a pass for me, finally. All right, level 13 to level 14, it's saying the password is stored in this. let's see, Bandit pass Bandit 14, and can only be read by user Bandit 14. So we get a private SSH key that could be used to log into the next level. So let's take a look at it. SSH key.private. So if we look at that, we get a private key. So what we're going to do is copy all of this, and we're going to have to exit out and go back to our local machine. So now that we're in our local machine, we have to vim, let's see, we'll call it Bandit 14 key. Paste that in there. Right quit so it saves it, and we have to change the permissions of the key to 600. That's what an SSH private key will need. So then the command we'll use is SSH-I, using that key to Bandit 14 at bandit.labs.overthewire.org, and the same port, 2220. So we're here, don't need to enter a password because we have that private key. So if we take a look in here, oh, that's right. It's in etc bandit pass bandit 14. Come back here, that file, and there's our password. All right, level 14 to level 15, it's saying the password can be retrieved by submitting the password of the current level to port 30,000 on localhost. And so the easiest way to do this is with this program netcat or NC, and basically it's one of the easiest ways to be a client to a server. And so logged on to Bandit 14, we're going to do NC, and it's saying to do it to localhost port 30,000. Localhost 30,000. Yeah. So it doesn't really show anything, but if we submit that password, it says correct, and gives us the new password. All right, level 15 to level 16, saying the password can be retrieved by submitting the password of the current level to this port on localhost using SSL encryption. So SSL, Secure Sockets Layer, it's kind of outdated now for TLS, but the way we'll use that is this command, OpenSSL. And what we'll need to do, we'll scroll down a little bit, we need to use S-Client, implements a generic SSL TLS client, establish a transparent connection to a remote server speaking SSL. So that's exactly what we need. So we'll do OpenSSL S_client, and we need the -connect. We spelled it terribly. Connect to localhost : what was the port? 30,001. 30,001. And so here's all the stuff for sending SSL. We'll submit our current password, right? Submitting the password of the current level to that port. So submit the current password, and it says correct, and gives us the new password. All right, level 16 to level 17, saying the credentials can be retrieved by submitting the password of the current level to a port on localhost in the range 31,000 to 32,000. So we'll be using this tool called Nmap, and I'll take you up to the top. Nmap is a port scanner, and it does a lot more than that, but for right now we're just going to be scanning ports, and we're going to use this option, -SV, probe open ports to determine service version info. So you can come here and map SV, and -B will give us a port range 31,000 to 32,000 on localhost. And we'll let that run for a second. All right, so Nmap finished up, and we see there's two ports that are running SSL. And this port 31790 is giving us some issues, and we can see it's actually entered the correct password. And so what we need to do is actually just do echo. This is our last password, and we'll send that to OpenSSL, same as last time, s client dash connect localhost colon 31790. And we'll do dash quiet to keep all the output away because we just want to see the password come out. And nice, correct. And this is the private key for our next level. Copy that, exit out of here. What level are we on? 17. Vim Bandit 17. Paste that in there and change the permissions again. All right, level 17 to 18. There's 2 files, password old, password new. The password is the only line that has been changed between password old and password new. So for this, we're going to use this command, diff, which is exactly what we need, compare files line by line, and I'll show you how it works. Diff passwords.old and passwords.new. And we see that line is in the old one, and this line is in the new one, so this is our new password. All right, 18 to 19, password is stored in a file called readme. Someone has modified the bashrc to log you out when you log in with SSH. So we could try that right now. Bandit 18. That's the password that we have. And bye-bye. And so the way we could solve this is actually just sending a command after we log in with SSH. So to send a command, we'll just do cat readme. And we'll see what that gives us. Enter the password, and there we go. There's the password for level 19.
Okay, so Bandit level 19 to 20. To gain access, use a setuid binary in the home directory. Execute it without arguments to find out how to use it, and the password is in the usual etc bandit pass after you've used the setuid binary. So let's go back to that. Let's find that binary and let's try to execute it. Bandit 20 do, and run a command as another user. So we're going to run a command which is ID after Bandit 20 do as Bandit 20, and right now we are Bandit 19. So let's see what's in that etc bandit pass directory, and there we have the Bandit 20 file. So if we try to cat it right now, Bandit pass Bandit 20, permission denied because we are Bandit 19. So let's make sure that the permissions are correct for that. So instead of cat, we'll do ls-l, and we can see Bandit 20 is the owner and the group. So we do the Bandit 20 do, and we can run that as for cat, and there we get our password. Alright, level 20 to 21, set UID binary in the home directory. It makes a connection to localhost on the port you specify, then reads a line of text from the connection and compares it to the password in the previous level. So what we essentially need to do is have a listener sending the password, and this su connect will read that password and give us the password for level 21. So the easiest way to do this is to echo the old password, and we'll use netcat again, but we're going to use a new option. So -l does listen for incoming connection rather than initiating a connection to a remote host. So that's exactly what we want to do. and nc-l localhost, and here we choose our own port. So I'm just going to do 4 ones. And important is to put an and after that to put it in the background. Ooh, it's already in use. Never mind. Let's change that to 8787. I don't know. I'm just making up a number. Alright, so then we'll use the SU connect at 8787. Reads that, password matches, and we got our password for level 21. Alright, so level 21 to 22, a program is running automatically at regular intervals from cron, time-based job scheduler. Look in etc cron.d for the configuration and see what command is being executed. So we're looking for something to do with Bandit 22. So cd etc cron.d. And let's look in here, and we see this cron job bandit 22. So let's cat cron job bandit 22, and we can see what it's running. It's running user bin cron job bandit 22.sh and throwing away the output. So if we take a look at that file, let's cat that bin bash and change the permissions for itself so only it could see it for this crazy temp folder, and it's putting the password basically into this temp file. So we could just look at that temp file, cat temp that, and there's our password for level 22. Alright, level 22 to 23, same kind of thing, program in cron.d. And let's go see it. cd etc cron.d, and let's cat cron job bandit 23. Okay, it's doing the same kind of thing, running an sh file and throwing it away. So let's copy that and cat that sh file. My name is who am I am user my name, md5 sum. Okay, copying password file to bandit pass. This is going to be bandit 23 because we need bandit 23. So that's going to be the result of who am I, because we can see bandit 23 up here is the one who's running it to temp my target. So if we just take this and copy it, we could throw it down here and change my $sign my name into bandit 23 and run that md5 sum and cut it, and it spits out this. We'll copy that, and it's copying the password file to temp and this md5 sum we just got, and this should be the password for bandit 23. Alright, level 23 to level 24, same kind of thing, cron job and etc cron d. So let's go take a look at that. cd etc cron.d ls, let's cat cron job bandit 24. Okay, doing the same kind of thing, running this sh file for bandit 24 under the user bandit 24. So let's take a look at what that sh file does. Runs it as bandit 24 for name, cds in a var spool bandit 24 foo, executing and deleting all scripts there. So for I and that, it basically looks at all the files. Let's see, where does it actually run it? If owner is bandit 23, timeout, and then run it. Okay, so within a minute, anything we write into this folder should be ran technically. So to start this off, let's make a new temp directory, temp my temp, cd temp my temp, and what we need to do is touch get password.sh, and let's start writing to it. So first step in a bash script is writing the shebang, which basically tells it this is how you run it. So we want it to run with bash, and all we want it to do is run one command, and so we could do that by putting a $sign and parentheses, and what we want it to do is cat etc bandit pass bandit 24, and we want that to go into etc our temp directory, temp my temp, and let's just call it pass. I think that'll work just fine. Okay, so that's our sh file, and right now we just have the sh, so let's touch pass, that file we're supposed to be throwing the stuff into. And so right now only we own the files, so I want to do get password sh and pass to have the permissions for everyone to read, write, execute. And you can see it right here, they both have those permissions. But what we need to do now is copy get password.sh to var spool bandit 24 foo. Alright, so the cron job should pick it up. We gotta give it maybe a minute, but yeah, I'll come back to you. Okay, so we actually got the password. It ran the cron job, and this should be the password to level 24. Alright, level 24 to level 25. The daemon is listening on port 30,002 and will give you the password if given the password for bandit 24 and a secret 4-digit code. There's no way to retrieve the pin code except by going through all the 10,000 combinations. So I'll show you guys how to print out the 10,000 combinations right now. We could do a simple for loop for I in open brackets 1 through 10,000. Do echo I, and that'll print out the numbers that we're going through. Done. And you can see that goes through all of them, 1 to 10,000. And so we're going to use this, but instead of echoing I, let me clean it up a bit. Instead of echoing I, we're going to print our previous password. And then we're using printf so we can actually control the amount of digits. So %04d, and this is a C function, but it's also a Linux function, and a new line. And what are we going to print? Well, it's going to be $I. Okay. So we run that, and we're basically printing 4-digit codes from 0000 to, I mean, not 10,000, but it'll go up to 9999. So after we do that, we feed all that output into netcat, and it wants us to go to port 30,002 on localhost. Netcat localhost 30,002. Right, that's it. Yeah, 30,002. And if we do that, it'll basically give us a bunch of wrong answers and the right answer. If we want to clean it up, a little trick we could do is grep-v, and right here -v is invert the sense of matching. So basically anything that doesn't contain the word wrong will be the right answer. Password for Bandit 25 is this. Alright, level 25 to 26, it says logging into Bandit 26 should be fairly easy, but the shell is not bin bash for Bandit 26. So, just looking around in Bandit 25, we have an SSH key for Bandit 26. So, let's first cat that and make our own key. So we copied that, but something we also need to see is what shell is Bandit 26 using. So we could see the shells by catting etc password, passwd, and that should list all the users. So let's go through it. Bandit, let's see, where's Bandit 26? User bin show text, and everything else is bash, except for some of them. So let's find out what user bin show text is. Cat user bin show text. Exec more on ~text.txt. So it's running the more command on some random text file. So let's go and exit out of here. Vim bandit 26 key. Let's paste that private key into there. Right quit. Change the permissions. Bandit 26 key. SSH-I. We'll just use this last command and change the numbers. Bandit 26 and Bandit 26 key. Alright. And basically this is what's in that text.txt file. So we knew it was running more, so a little trick we could do is reduce our terminal size. Reduce our terminal size super small and SSH again. And this time more won't be able to display everything. So what we could do now is in the more command we could press V, which goes into Vim mode. Okay? And we could see that I don't want to bring it all out, but once we're in the Vim mode, we can change the terminal. So set shell equals \bin bash. And after we set that, that'll just be for this session. We could run sh, and here we have it. We have a shell for Bandit 26, and we could see what's in here, and that's for the next level, but we can see the text it was displaying was that. And so basically, same as usual, we'll get the password, cat etc bandit pass bandit 26, and there we have our password. Alright, level 26 to level 27, good job of getting a shell. Now hurry and grab the password. We already did something like this before. We have a bandit 27 do, so we know we could just run that bandit 27 do cat etc. Oh my god. Alright, well, you're gonna see me go through all those steps again. Let's do that. Get the key, more, V, set shell equals bin bash. Sorry, we're just speed running level 26 right now. And then sh. Okay. And we're back. Let's do this really quickly. Cat etc bandit pass bandit 27. And there's our password for 27. Alright, level 27 to 28, it's saying there's a Git repository here, and the password for the Git user is the same as bandit 27. So really quickly, let's make a temp directory, and here's a little trick for a temp directory I haven't been using, but let's use it now. Make temp d, and that just makes us a brand new temp directory. So I'll show you a problem that comes about with this one. So if we just try to SSH or git clone it using the SSH, we'll type yes, and it says permission denied because we're trying to SSH on port 22. So what we have to change is right after the word localhost, we have to do 2220, the same port that we've been SSHing on. Once we enter that, yes, enter the password here, and there we go. So we got the repo cd repo, and what's in here? Just a readme, cat readme, password to the next level. Okay, level 28 to 29, same thing, git repository here, and a password for that is the same as bandit 28. So let's cd into make temp -d, new temp folder. Let's git clone that. Yes. Oh, I forgot. I literally just said it. 2220 as the port, and that should work. Yes. And the password I have saved right here. So let's slap that in. Okay. Now let's see what's in this repo. So we look in repo. We cat the readme. Some notes for level 29. So we have the username and the password has been omitted. So one thing we can do, we know it's a Git repo. So if we do the git log command, we'll see all the different commits. And here, initial commit of readme, add missing data, and fix info leak. So if we do the git diff, which will show the difference between two git commits. The difference between that commit where they add the missing data and the most recent commit. Let's see. So we see the password changed from the real password to all X's. And right here we have the real password. Alright, level 29 to 30, same thing, git repository over here. So let's do our temp directory again. Alright, git clone bandit 29, and this time I won't forget, change the port 2220. Yes, and the password I saved right here. So let's slap that in. Okay. cd repo. And let's see what's in this readme. No passwords in production. So let's see. We'll try the same thing, git log. There's only 2 commits, so sorry. Control-Shift-C to copy. Git diff between that commit and the latest commit. And we just changed it from 29 to 30. So nothing of interest, but what we can do is, because it's a Git repo, we can see which branches they have. So git branch lists all of them. So this is the branch we're on: origin dev, master, and exploits dev. So we could just start from whichever one we're not on. So let's start remote origin dev. So the way to switch branches is git checkout remote origin dev. Alright, now let's see what's in here. Cat readme, and there's the password. Alright, level 30 to 31, same kind of thing, git repo over here. So run through the exact same steps. cd make temp directory, git clone bandit 30, change the port 2220, same one we've been using. Yes, and the password I have saved right here. Throw that in. Alright, let's see what's in repo. There's a readme, so cat readme, just an empty file. So let's go through the same steps. Git log to see the commits. There's only been one commit. Git branch -a master and head, which is the same. So there's only one branch, only one commit. So one thing that we have to think about is there's a thing called git tag. And tags in Git are basically a way to mark big points in a repository's lifespan, like maybe version 1.0 to version 2.0 or something. So let's see what tags are in it. There's a secret. So it's literally called secret. So if we use git show, we could see what's in the tags, and this definitely looks like a password to level 31. Alright, level 31 to 32, same kind of idea. Copy the git repo. Actually, I still have that password saved, right? Okay. Yeah, copy that git repo. Let's see. Take this, copy that. cd make temp directory, git clone that repo with the right port. Yes, grab my password I just saved. Alright, cd repo, let's see what's in here. Cat readme. Your task is to push a file to the remote repository. So we gotta push a file called key.txt, so let's just make a blank file called key.txt with a touch command, and touch just makes a new file. So now we have here key.txt. We can see with git status we have not pushed it yet. So git commit -m. Oh, actually, hold on. Let's see readme. Content may I come in. Alright, well we gotta add that. Vim key.txt. Let's just add that. May I come in? Question mark. Right quit. Okay. So let's do a git add, and this will add it to the repo. Following paths are ignored. Okay, so somewhere in the git ignore file it's purposely ignoring our key.txt, but that's okay. Git add -f is the force option, which basically ignores that git ignore. Alright, now we have it added, so we could see that, and it should say an unstaged, yeah, ready to be committed key.txt. So let's go ahead and commit that. Git commit -m for message, and then key.txt. I don't know, we'll keep it simple. Alright, git status again. We're ahead of master by 1 commit. So now we could do a git push. Yes. Grab that password again. Well done. Here's the password for the next level. There we go, level 32. Alright, level 32 to level 33. After all this git stuff, it's time for another escape. So, we logged in, and it says, welcome to the uppercase shell. We try to enter anything, and basically it uppercases everything. So we can't really do much. Cat is not found. So yeah, these aren't the real commands, because it's making our command into an uppercase. Something we can do, it basically takes us back to the fact that we know it's running sh right here. So if we look at sh, the man page, we could read right about here, right? The first argument is the name of a file, right? The remaining arguments are the positional parameters of the shell. So basically sh would be from this, sh would be $0 and ls would be $1, because those are the positional parameters of what it's running. So we could just do $0, and that should be sh, and there we have sh. And from here we could do bin bash just to make it a little bit easier, and here we are at bandit 33. And so let's just do the old classic etc bandit pass bandit 33, and there's the password. Alright, well, we've come to the last level. So they don't have a level 34 yet. It's been a couple years. I really don't think they're gonna have a level 34, but we can see what's left for us here. There's a readme file, cat readme. Congratulations on solving the last level. There are no more levels to play in this game. We're constantly working on new levels soon. So yeah, that was Bandit. Pretty fun to play, pretty easy. Basically teaches you the basics of how to use the shell, how a couple shell scripting ideas are put in place, and a little bit of Git. So I hope you guys enjoyed this. I had a lot of fun doing it, and we'll come back and do more of these war games. I believe they have a couple. So yeah, we'll come back and do all these. Alright, see ya.